guest. Our next guest is Dr. Arnd Menschig from Zeiss Digital Automation and Innovation Center called DIDIZ. DIDIZ, right? DIDIZ. And Arnd is a true expert in the field of process industry. He has been in digital automation and innovation, sorry, that's what I wrote down. And he will tell us about digital twin building during asset production and initial operation. Is that correct? Yes.
Thank you for the invitation. Thank you, the organizers, to invite me and to have the possibility to share the knowledge with you. In the moment, we are not part of the OI4 consortium, so hopefully in the future, at least the Scale-It cooperative is part of, as a member within some projects. I will not focus on Zeiss. Nevertheless, I have three items in the main, the Industry 4.0 architecture we use in this innovation center. Also then the uniform data provisioning there. And it's in the last few weeks also the digital twin building efforts. So in the introduction, yes, first Zeiss, I think all of you hopefully know it, and hopefully some of the machines are already also here working at Multivac. The industrial quality solutions combines the standard CMM technology. Also now the robot technology former comes from GOM, and a lot of other technologies as Röntgen tomography, X-ray, industrial microscope, and optical systems for applications. The main focus why I'm here is Innovation Center, the DIDIZ of the AHK Ostwürttemberg. We have there the possibility to really realize technologies in a very open environment. And you see here three different, let's say, locations of this center. One is in Schwäbisch Gmünd, focusing on smart factory. One is in Heidenheim, focusing on mixed reality and 3D. And the one here is the location in Aalen, where we have Industry 4.0 as a venue in the test lab. And you see some examples we have there showing that we are not working theoretically on digital twins, but really bringing digital twins to life. And for this, we have software applications there, sensorics, e-labeling technology, very interesting communication solutions with ultrasonic, infrared, and 5G, and that's also artificial intelligence use to solve problems. There are a lot of companies in this digitalization center. It's mainly Ostwürttemberg, so most of them you do not know, I think. And yes, as we agreed with Ricardo and Ekrem, so we will, the Innovation Center will become a sponsored membership application, so we can start working together. The next thing I'm here is Scale-It Cooperative. I think we have there let's say, a focus that is compatible with the one here at the OI4. The Scale-It Cooperative offers an app store and also a marketplace where you can buy different things, and organizes the life cycle of the apps. And there are some specialities here. I think we are on the way to really make it simple. Simplicity is one of the main items where we work on. And because I'm not an IT specialist and I want to use all these things, we do it really simple. And therefore, the first thing is the cooperative has to supply a container infrastructure, web app templates that the members can build apps, and also the ecosystem definition. This one would be special interest to align it with the OI4 ecosystem definition. So as suppliers can build web apps in an easy way. then the web apps come back to the App Store, and maybe there's a difference between the App Store of the OI4 and our App Store. Our App Store contains really products. It's not based on a repository. We have complete ready apps in it, and we supply this. So if we build the business cases, the customer can buy the product at the marketplace. Through the marketplace, an order will be created and the app transferred to the customer. And the App Store technology is open to other shops, to other marketplaces. So I will be happy to, yes, cooperate in the project of this initiative here. Okay, I think also here, I named it, we hopefully can start a project partnership with the OI4 Alliance, and yes, it will help, I think, both sides. The architecture, it's really based on a network architecture. We use with a three-zone concept. Some of you maybe know this three zones, the corporate network where we have access to the internet. The yellow zone, which is over different platform networks. And the idea is to have a solution that if we install software at the platform network, we need no internet connection. This is one of the things why we would have ready apps in the store, so we can supply it even to platform networks. In a research in a joint venture project of the Ministry of Economy and Climate, we had things about how can we realize the transition from the automation period to the Industry 4.0 platform. I will not go deep into this. You know, smart factory, everyone should have connection or the possibility to talk with others. So if we go to the sensor data transition, we see the main focus is not to bring sensor data to the cloud. The focus is to work with sensor data, even in the operations network, for example, have data available in the corporate network for the different applications, and the data that should be in the cloud, it will be transmitted to the cloud. So on the other side, we have to think and solve the problem how to get the software down to the platform networks. And here, the idea is to have at least a part of a technology in the corporate network where we can access to the marketplace, access to the App Store in the cloud, do some tests within this application, set parameters, and maybe also solve security issues of the app, and then bring it down in my own in the network. The next one is a very complicated, let's say, view to this technology. I think it starts in the gray area where we have the continuous development integration scenario, build the apps, really ready apps, and then put these in the app store. All technology is web technology. It's let's say a cloud-based, cloud-agnostic technology, and then from the App Store you can use the scaled technology to have a view on these apps in this, for example, app pool that runs in the green zone, and then put apps down to different devices in the shop floor. And there are a lot of colors in it because this technology is used there, offers a solution for a lot of providers of software. And so also the whole application can build of different parts. And I hope we will have in the future an open, multi-vendor capable distributed edge computing platform because also the OI4 consortium is working on this technology. Now look a little bit what we have realized in the digiZ. Is there a kind of test lab enterprise we built up there? We have these 3 network zones. We have a connection to the connected world, to the internet, because the developers need connection to the software quasi that is tested there. And then the first idea is to connect different zones in a secure way. So we have devices where we have on the one side a Windows application to use a browser for the web technology, and on the lower network side we have the web technology platform to use all this nice Docker technology that's available. So we can connect these different network zones by firewalls, and hopefully all security engineers are happy with the solution. In another research project, it's the FabOS, where we build together with a lot of partners a kind of operating system for the shop floor. There we have the first quasi Kubernetes TSN solution if we really want to maximize the operability. Then in another project, we combined it with the Edge Cloud solution from Bosch, and actually we're working on the whole solution going from shop floor up to the internet, or from the internet down to the shop floor with interesting partners there. This is actually running a joint venture project, the software-defined manufacturing project. So there is really a production background there, and we built a very large demonstrator in the moment in this digitalization center. Okay, next up is not so interesting, I think, than the uniform data provisioning. I think I bring in the idea. It's the main topic. I think it's also in your organization the main topic. We decided to define it together of 4 different issues. It's an identification provider that gives typically a number, the global actor that gives the company an identifier. Then for the item itself, for the articles, we have the item number, and for the serial number. So this gives us an unambiguous global instance identification assigned by the manufacturer. So this is an example here for the Zeiss IMT facility in Aalen, and that's typically product. So, but with this definition, also other, let's say, company identifiers are possible. For example, the URL usage or the IO link usage. So if we take this specification, or if we can agree to this specification, I think all needs can be fulfilled. Then for the communication, for sure, we work on Ethernet. We have on the one side the public and subscribe technology with MQTT, on the other side also REST, server-side events or WebSocket communication, depends a little bit on the application. But the main thing is to put a common data structure on it. For this, we use a JavaScript object notation, and we started, I think now 10 years ago, to put in a semantic annotation in these JSON data, so that everyone talks the same language, and we can build a lot of applications on it. And what we have to do there is really have also some definitions of the topics we use on the MQTT side, and also on the endpoints on the other side, because the goal is a platform technology, and if every user does his own thing, it will not fit together. For this, Zeiss organized semantic annotated data structures definition with a lot of yes, our coworkers are happy with. And in the future, we have also now to adapt the OPC-UA technology, which in the moment it's not used by us. So the semantic annotation really uses SI units. This is very important. We agreed in our corporations to use IEC CDD definitions for a lot of things, and to use the semantics to really have a definition how the data is provided on a broker, for example. For the topic definition, yes, I think we divided this in 3 parts: the pre-topic, the global asset ID, and the post-topic. So this is a little bit organization, and if we use there the RAMI 4.0 definition of the hierarchical architecture, we can use also filtering mechanisms of the broker to decide which kind of data is interesting for us. Yes, you see here now we started to work with digital nameplate or with software nameplate. So the IDDA definitions coming also in our in our use in our thing. I think this one is a little bit too detailed. Nevertheless, we have the ID. Here is typically the global asset ID. The whole semantic structure is divided in 3 parts. We have the semantic definition, because not everyone will use the same semantic. We have a part of the security definition, who is the publisher, who is the receiver of the data, and very important, we should use the same timestamp definition. So here we use UTC ISO 8601, that timestamps can easily compared. The third point is the data. There's also a timestamp in it. It's not the same timestamp as the other one, maybe, because it's a timestamp of the real measurement value. And the content is, yes, I think the main thing we have to discuss, which we put in. So I say it's open to further alignment with other activities, and, for example, to align it with submodel data of the AAS. Then, yes, we have sensors. A lot of sensors in this showroom there from different suppliers. In the here, I only listed Zeiss, Siemens, and Bosch, but there's also IFM available there, Baluf, and other suppliers. It's not only suppliers of this OI4 consortium, there are also other ones. Then we have to make this OT to IT transition. I think it's also discussion in your point. So we do this OT to IT transition in the edge gateway, so that all the data is put in the same uniform version on the broker, and then different services can work with this data. For us, in Zeiss, we built a sensor twin application. It directly uses the sensor data on an interface, and yes, because we use web technology, we can use the browser on different client devices. We can make it more complicated to really have persistence services, and to use this and different also interface services to view all this data on the web browser. And I think the main thing we have to come is a common understanding of the data according to a kind of semantics 1.0. We have 1.0 semantic. Maybe it has to change if we go here into this OI4 cooperative. The digital twin building, yes, we start the same. We start with the sensors. We start with a hardware-specific interface to the sensor. This is a microservice architecture they are built. So this is the one that is specific to the hardware. Because we like to have data, twin data, we adapt a Docker volume to this service. So in this Docker volume, we have the information about the twin. Then we have a standard data interface service. We have a standard user interface service. So this is the first self-contained sensor twin where we can view the twin information on the client device in a web browser, and we can make it more complicated. Because we use REST interfaces, also applications on an edge platform, for example, app management or asset management, can use this information. Also, we can use, let's say, data services that gives some predictive information by using AI algorithms. And also, we can make the sensor twin itself more complicated to have there also a persistence technology. And for the time series data, we are willing to use the IDTA submodel that easily can be adapted to activities here in the cooperative. So, yes, the security issues we solved in a scaled joint venture project using sidecar security services. In the moment, they are not active, but this will be in the near future to solve this. This is a short view on the data we have within the sensor twin. We have the software data, the software nameplate, we have the equipment data, the digital nameplate. This is a kind of file architecture, so we can add other data and also view it and edit it in the future. And here within this, we have all the documents that described here in the sensor application, mainly the digital calibration certificate or the calibration certificate as a PDF version, or in the certificate part, the digital versions of the digital calibration certificate. Yes, coming to an idea, yes, beginning with the same architecture I discussed some slides before. I think we can now build together a whole, let's say, application using sensors out of the OI4 Alliance, gateways, edge controller, some software solutions to really bring everything together and also to adapt it. The whole infrastructure is existing. We only need sensors, maybe gateways that should be included in this, let's say, innovation centers there. And the innovation center is open to visitors, is mainly open to the partners, is everything organized by the team. So coming to the AAS building, we have also some ideas because on this joint venture project, we started to bring sensor calibration data to the sensor twin, and then using this scaled transfer and deployment technology to bring the sensor twin to the customer, started there, and and put all the data on the MQTT broker. Now we can, yes, add to this the information of the submodels, but not using submodels completely as a AAS, but a reduced one as a JSON data, because JSON is familiar in the companies, or more familiar than the AAS. Nevertheless, the AAS technology, the AAS infrastructure will be used to bring all the data together. And yes, this was a result. We're working on the software-defined manufacturing project, but we can also, let's say, put this together with a consortium here. I think this was it. You can.
Thank you very much, Dr. Arnd. So everyone can visit the DIDIZ Center in Aalen anytime, or are there?
Not really anytime. It should be agreed time. Yes, yesterday, for example, Dominic was at the innovation center and had a look, and I think he was very impressed. And Ricardo and Ekrem were also, and we visited also. So yes, we can agree for, let's say, a visit, but I think it's better to agree for a workshop than for a visit.
Yeah. Okay, thank you very much. We do have 3 questions, but not that much time. Maybe you want to answer one of those questions?
We use IDGA concepts, but we started 10 years ago, so it's not completely, finalized. Yes and no with this Dean spec, because I think it's too specialized, I think, for the applications, and semantic ideas. We have to think how to solve it. Also, these semantic ideas. Because with the definition of the global asset ID, I think we have the possibility to agree with these other providers.
Okay, thank you very much.
Okay.
Thanks.
Thank you for listening.